OpenAI's Codex just built a complete 3D chess game as an Electron desktop app. Glass and marble pieces. Gallery lighting. Click-to-move gameplay. Castling, en passant, checkmate detection. And then it tested itself using Playwright end-to-end tests. From a single task prompt. 1,821 lines of code across 8 files. Then, just to show off, they uploaded a wireframe image of a coffee shop website and Codex turned it into a fully designed, responsive website with real content and images. This is Codex Tasks running locally on GPT 5.4, and it changes what a single developer can build in an afternoon. So what are Codex Tasks? This is OpenAI's coding agent that can take a high-level instruction, like build me a 3D chess game, and autonomously plan the project, scaffold the files, write the code, debug issues, run tests, and deliver a finished application. It doesn't just generate code snippets. It operates like a senior developer. It creates a task plan, breaks it into subtasks, executes them in order, and self-corrects when things break. In this demo, Codex is running locally on the developer's machine using GPT 5.4 at what OpenAI calls extra high effort, meaning the model takes its time to think deeply about architecture and edge cases before writing a single line. The result is production quality code, not prototype junk. Let me show you exactly what Codex built. This is the real demo from OpenAI's developer team. The developer gives Codex a task with 3 clear subtasks. First, scaffold the Electron project with dependencies and baseline app structure. Second, implement the 3D chessboard with glass and marble materials, lighting, and click-to-move gameplay with full chess rules. Third, launch the Electron app with Playwright and run end-to-end tests for castling, en passant, and checkmate completion. Codex starts executing immediately. It installs dependencies, builds the app structure, and starts writing the 3D rendering code. But here's where it gets interesting. When Codex runs into a bug with the Raycaster hit testing for clicking chess squares, it doesn't stop. It identifies the problem, explains that it's a prospective hit testing issue on upper board squares, and fixes it by implementing a renderer-side search for clickable coordinates. Self-debugging in real time. Then it runs the full test suite, confirms all rules pass, and does a visual check on captured Electron screenshots to verify the materials and lighting look correct. The final result is stunning. A 3D chess application called Glass Marble Chess with frosted glass white pieces, polished marble black pieces, gallery lighting with warm golden reflections, coordinate labels, move notation, FEN string display, and drill scenarios for practicing castling in en passant. 1,821 lines of new code. 8 files changed. 1 single prompt. But they didn't stop there. The developer then uploads a wireframe image, a PNG mockup of a coffee shop called Nancy's Beans, showing the layout, navigation structure, menu items, and placeholder image positions. Codex takes this wireframe, understands the design intent, and builds a complete website. Not a skeleton. A finished site with styled typography, curated coffee imagery, a responsive grid layout, a signature lineup section, and descriptive copy that reads like a professional copywriter wrote it. Let me explain why this matters more than every other AI coding demo you've seen. First, Codex runs locally. That local indicator at the bottom of the interface means the agent is operating on your machine, accessing your file system, running your terminal commands, and using your real development environment. No cloud sandbox. Real development. Second, it self-debugs. When the Raycaster bug appeared, Codex didn't ask the developer for help. It diagnosed the problem, proposed a fix, implemented it, and verified it worked through automated tests. That's not autocomplete, that's engineering. Third, it writes tests. Most AI coding tools generate code and hope it works. Codex generated Playwright end-to-end tests that verified castling, en passant, and full checkmate detection. It tested its own work before delivering it. And fourth, GPT 5.4 at extra high effort. This is the full power of OpenAI's latest model, taking its time to think through architecture before writing. The result is 1,800 lines of clean, tested, working code. Here's the uncomfortable truth for the software industry. A single developer with Codex Tasks can now ship in one afternoon what used to take a small team a week. A 3D chess game with full rules, automated testing, and polished visuals? That's a sprint's worth of work for a team of 2 or 3 engineers. A wireframe to website conversion with real content and responsive design? That's what agencies charge $5,000 to $15,000 for. Codex did both in the time it takes to drink a cup of coffee. This doesn't mean developers are obsolete. You still need someone who knows what to build, how to evaluate the output, and when to intervene. But the ratio of what one person can produce just shifted dramatically. The developers who learn to direct agents like Codex will build 10 times more than those who don't. That's Codex Tasks. Building a 3D electron chess game and converting a wireframe to a website, all running locally on GPT 5.4. Link to the original demo is in the description. If you're a developer or founder, stop writing boilerplate and start directing agents. Subscribe for daily AI breakdowns. We cover every tool that changes how software gets built. See you in the next one.